Hello everyone. Today we are going to go through fair rotations, which is a problem on the implementation section of algorithm on HackerRank. So without wasting time, let us have a look on the problem statement. So in this problem statement, we are supposed to find out if we can obtain or not a list of even number from a given input by performing a given type of operation. So we are receiving as input an array that can contain even and odd numbers. And then from the array, we are supposed to look through the element. And then whenever we are going to meet an odd number, we can give one, like we can increment that element. And by incrementing that element, we are forced to increment either the element directly before or the element directly after. By proceeding so, you're supposed to find out, is it possible to have all the number even? If it is the case, how many elements do we need to increase or to add in order to have the result? If not, we should return no. So in this scenario, let us take this one for instance. We have an array consisting of 4, 5, 6, and 7. So let's see that you have 4 here. 4 is actually even, so you can leave it. Now you come to 5. 5 is an odd number. So what you can do is that you can increase, you can add 1 here. Now this one will now be 6. Since you added 1 here, you need to add 1 either in front or either front or either back. Now we are moving from left to right, so I would rather go with adding here. So at this stage, I will have 6 here, 7 here. Now at this place, what am I supposed to do? I can add 1 here and 1 here. That will give 8, 8. So at the end, I have the result 4, 6, 8, 8. Now, how can we, this was an example of how the problem is supposed to work. Now, how can we implement the approach? What will be our approach of solving this algorithm? So if you're not yet subscribed to the channel, I really encourage you to subscribe to not miss what we are doing here in terms of data structure, algorithm, and problem solving. So to solve this, we are first going to consider like, okay, we are going to take, let me take this one for instance. We have an array of elements, we have even number and we have odd number. So we can go with the idea of moving from left to right and say, okay, whenever we are going to meet an element which is odd, we add the element by 1 and then we add the element next to it. And then by doing so at the end, if at the end we have an array with only even number, then we were able to have the result. And then we are going to return that element, in fact the number of element that was added through our process, as the number of element need in order to have the result. Otherwise we just return no. Now you may ask yourself, you're talking about minimum, are we sure that moving from left to right will always give the same result as moving from right to left? Because if we are not sure of that, that means we cannot rely on the fact that moving from left to right will be enough to have the solution. Okay, so what I think is that it will be the same. They are going to be the same. Why are they going to be the same? Let us take this one for instance. If you are moving from left to right, this one, all the even number are not going to be touched, right? The first one that's going to be touched is the first odd number. Okay, and then this one being affected will affect the other one and may affect the other until the last one. So if after this 9 we have any number here being affected, that means you are not going to have a result because the rest of the number are actually odd. So if are actually even, sorry. So if after the last odd number you still have to update element, that means we are going to have something that is going to return no. Given that, that means our result is actually will actually be a transformation of the longest substring consists of the longest substring starting with odd number and ending with odd number. So basically, if you are going this way and this way, basically this is the part that's going to be transformed. So you are sure that you are going to have the same array at the end. If you don't have the same array, that means it's not a possible solution. Okay, cool. So now given this, how are you going to proceed? We are sure that moving from left to right or right to left is the same. So no need to care about that. We are just going to take one side, and in our case, we are going to move from left to right. So we are going to move whenever we are going to meet an odd number like this one. We are going to increment the number, the current number, and increment the number next to it, and we are going to loop until the last element, until the element before the last element. If at the end of our loop the last element is actually even, that means it is a solution. If the last element is odd, that means it is not a solution. So the first thing we need to have is to create our result that will keep the while moving. We are going to increment our result that will contain the number of loaves or the number of elements that we have added throughout our process. We are going to need a for loop that is going to loop from the first element to the element before the last. And for each of the elements, like I said, we need to increment that element and increment the element next to it. But we don't really need to increment the element on itself because we are not really going to use it anymore. We are moving forward, so we can just rely on updating the next one. So that's why b of I plus 1 plus plus. And by doing so, at the end, if the last one is actually an even number, that means, yeah, it is possible to have the solution, and this result is actually the result that it is actually the number of loaves that we need to add in order to have all of them being even. Now, if not, if the last one is an odd number, that means we have an array where all of the elements are actually even, just the last one is an odd number. That means basically we can't have all of them be even number, because no matter what you're going to do, you're always going to find yourself adding two loaves, because you have to add to the element, and either to the element next or the element before. So you see that if you have all of the elements be even, just the last one is not even, that means you cannot have all of them even. So there's actually no solution to this. No. So this is my approach of solving this. Let me run and see what it gives. Let me submit. So everything perfect and green. So this is my approach of solving this. I hope you do enjoy it. Feel free to leave me a message in the comment section if you have anything to share related to this. See you on the next video. Ciao.